is equal to what? B squared is equal to GM over R. In this case, will be the distance from the planet to the sun. On the other side, we know that V is the distance over time. If the Earth is moving in a full circular path, how much is the distance covered in 1 year? If it's a circular path, what will be the distance covered by the Earth in 1 year? It's a circle. 2 pi r. So 2 pi r over what? How much is the time to complete one full circle? Which is, how did I call? How did I label?
1 year.
Yes, what is 1 year for the Earth? What is that? Physical magnitude.
1 revolution, 1 period.
1 period. T. So if I now pair these two equations, I can say that if I bring this V to here, so this will be 4 pi square r over period square. Is that correct? I just put 2 pi r over t here on V, and I square. And I have on the other side G m over r. If I cross multiply to get this ratio, I get t squared to this side, r to this side, 4 pi squared r cubed over, I put t squared to this, I put gm to this side, gm. Is that right? I just cross multiply. I multiply times this. I have r squared here because I squared the radius. So if I multiply r squared times r, what will be? R cubed. 4 pi squared r cubed, and I brought gm to this side and t squared to this side, cross multiplication. So if I move r cubed to this side now, if I divide by r cubed both sides, I will get t squared over r cubed is equal to 4 pi squared over gm. What is the mass? This mass of whom? In this case, what is the central mass? Earth. No, we are talking about the sun. This is the mass of the sun. This is g. This is 4, and this is pi. Since all of them are constant, the ratio of these two values will be equal to a constant, which is called the Kepler constant for the sun. So if you have the average period of the Earth, which is 1 year, and with the telescope you measure r from here to the sun, what can you measure? So if you have 1 year, and you have with the telescope the distance from here to the sun, what can we know? Yes, the Kepler constant. And what you have in the Kepler constant?
The mass of the sun.
The mass of the sun. So we can find the mass of the sun if we have the period and if we have the distance from here to the sun. So we can find what will be the mass of the sun approximately, because remember, we are making this now at this moment in this class a perfect circle, which is moving in a circular path. When it's not moving in a circular path, in an elliptical path, the calculation will be more complicated because we have an ellipse, but it can be calculated as well using calculus. Okay, this is basically the Kepler third law, which is this. Now, for two planets, what can we say? Because this is the same constant, we can say that T1 squared over R1 cubed is equal to what? If we have a second planet, what can you say? If it's constant, this ratio is constant for all planets, what can you say? For all planets on the Earth, on the solar system, what can we say? T1 squared over R1 cubed will be equal to what?
T squared.
T2 squared over R2 cubed. Means if we have the Earth period and we have the distance of the Earth to the Sun, and you have, let's say, the period of Jupiter, can you find the distance from Jupiter to the Sun?
Yes.
Doing this ratio. And this is also a ratio between two planets. Any questions so far on these 3 topics or 4 topics? First topic, force. What will be the net forces? I mean, the force is the gravity. The weight can be calculated in different locations and get the ratio. Acceleration due to gravity can be calculated at any location, and then you can compare between 2 locations. Then we studied what was the orbital velocity. We did the same. We find the orbital velocity formula, and then to relate between 2